Yeah. How are we? We are fine. Yeah, hope everything is okay. Now, today we are going to look at the next topic that follows directly from topic 3. I remember that topic 3 we saw fractions, percentages, and decimals, and that was pretty long because each was behaving like a very full topic, yet that was a subtopic. Now, today we are introducing the other fourth topic called the rectangular coordinates, called the topic 4 is rectangular coordinates. Then under here we shall have to visit subtopics here. That's plotting coordinates. Then we shall have to say plotting polygons. Then we shall see lastly drawing graphs. Now you should have the following. That means have a graph paper. Then also you should have a set. That means you should have a long ruler, and you should have also calculator for some few estimates and calculations. Now this topic is a bit very short, but I hope everybody is attentive, not so? Now before I can start the lesson, as usual, we have to check, because students can say we are attentive, yet they are not attentive. They are somewhere. Now I would like to check your head and your attention whether it's 100% correct by this small question. Listen and we see whether people's heads are working. If you happen to run in a race and you pass the person in the second position, which position do you become? All of you have answers. Which position do you become? Let us start with the first one here. You remind us your name?
My name is
Mokisaru Precious. Which position do you become? You become the first. You become the first. That's Mokisa Precious. Okay. Out of Mokisa Grace, what do you become?
You become the second.
The second?
Reason being, you have passed the second person in the second position, but you won't pass the first one in the first position. So you will remain the second.
Precious, is that very correct? That's very good. Thank you very much. You become the second. That has shown me that could one person be attentive or one is missing attention? Okay. Now, let us now start. we shall be checking the students like that. Now let us start with the plotting coordinates. But before we can look at plotting, we want first look at plotting coordinates. Now these coordinates are plotted on what we call a Cartesian plane. That was given, the plane is called the Cartesian plane. The word Cartesian was given in respect to that great mathematician called Descartes. That coordinates are plotted on a Cartesian plane. And what's this plane here? Descartes was the first mathematician to plot values and locate several things using the knowledge of coordinates. Of course, we can locate where you are seated by looking at measurements in different directions. Now, Descartes was the first to introduce to us what we call the Cartesian plane, which is made up of two we call them axes, which cut each other at 90 degrees. Descartes. See, math started as way back as man started. Yeah. Now a Cartesian plane is simply an XY plane. The other name we can call it ordinarily XY plane, which has two axes. Remember that when you are dealing with numbers do not end. They are infinite. Unending. To be infinite is to be unending. Now this was labeled Y-axis, and the horizontal line was the x-axis. Where they met was called the origin. The origin. The origin. And I'm very, very sure that you dealt with that in primary. You plotted the y-axis, x-axis. Now the division makes sure that it caters. The zero is introducing you to two values on a number line. I hope you recall integers, where zero separates positive integers and negative integers. Now the positive integers, of course, are placed up, and the negative integers are placed down for the y-axis. Now this on the left you have negatives. This type of plane is what we call the Cartesian plane. A plane is a surface. Now our surface is a sheet of paper. See? Now, to plot on a plain paper did not carry meaning. Therefore, there was an introduction of two types of papers. That's what we call the 1 centimeter squared paper, which is your graph paper. Some of you have it here. The 1 centimeter square graph paper. Why was it called 1 centimeter square? This one. Then there was the one which did not have small lines, which was just called a square. A squared paper. This is 1 centimeter squared paper. The other one was a squared paper. A squared paper, I've not carried one here, but it's normally used in most textbooks just as squares. Some books on market have squares, and that means plotting can be done either on a 1 centimeter squared graph paper or ordinary squared paper. Now, of course, the best is the 1 centimeter, which is clearly divided to even locate the smallest in case there are fractional plottings, like if you were plotting 0.5, 0.6, this paper is the best. Of course, this one cannot go up to plotting decimals, no? It becomes a bit tasking. So, yeah. Now, we want to first look at this paper and understand it before we can deal with the plotting, because now this is our communication plane that we use, the graph paper. The graph paper has importance in bearings, handling bearings. Constructions also must be done here. Then our Cartesian coordinates. I want you to understand this paper very well before we can go into plotting some examples here. Now, I happened to draw a few lines here, but with the interest of the fact that let me add just one column box here, and I'll only use it to explain the holograph paper. Use it to explain the holograph paper. Now, this is a 1 centimeter. Why is it called 1 centimeter? Now, that graph paper that you see here, it has bold lines. These lines are more thicker on your graph book. If you have it there, you can look at it. More thicker. Now, from here to here, if you use your ruler, it will measure 1 centimeter. One big square box. That would definitely be, you see, there are, hope you see that one here, each from one bold line to another is 1 centimeter. You can show that on your calculator, you can put your ruler there, you will measure it 1 centimeter. Yeah. Now, two of them will be 2 centimeters. And when you plot using 1 centimeter, we normally don't encourage that, because work will be squeezed. And we encourage using 2 centimeters, unless otherwise that things have looked a bit more difficult to deal with. Now, when we are plotting, the graph paper can handle smaller plottings. Maybe if you wanted to plot 1 or 2, it can handle that. Even plotting 50 with against 500, it can also do that. See that it can plot both small and big numbers. I hope that's very clear. Now, if you happen to label, we are discussing this graph paper. We are saying from here is 1 centimeter. That means 2 boxes is 2 centimeters. Yeah, that's very correct. Now, when we say when you are trying to conduct the plotting, you must understand what are you plotting for every 1 centimeter, what are you plotting for every 2 centimeters. If your axis was, say, at this point, this was the x-axis, and the y-axis was here, y-axis. Now, and your 0 definitely there. When you are locating this will be definitely the 0, then this will be 1, 2, 3, 4, and so on. Now here within each 1 centimeter there are 5 divisions. 0, 1, 2, 3, 4, and these are very many. That the graph paper has a big box, then smaller boxes, 1, 2, 3, 4, then 5. You see that? Now, when you plot this is 1 centimeter, that means the scale here, you have said 1 centimeter is representing 1 unit. 1 unit. You see that? If you happen to put 1 here, then these are now how many centimeters? These are now 2. The scale there, vertical scale there, we are discussing that, would be 2 centimeters for every how many units? 1 unit. Represent 1 unit. Now, if you are locating, say, assuming you wanted to locate maybe 1.2, you see now when you plot from here to here, how many divisions are there? Small boxes? There will be 10. That means when you are locating like 1 point something, 1.1, 1.2, 0.3, 0.4, I think 0.5, then 0.6, 7, 8, 9, 2. You see, if you happen because we are going to also plot big values. Let's say you are going to plot values which have intervals like a plotting like 100. That means you cannot say 0, 1, no? You can't say that. I will ask you, assuming you put the x-axis in the middle, how many boxes would remain up of your graph paper if you put the x-axis somewhere in the middle? How many total boxes are here? 1 centimeter?
I think there are 20.
There are 20. 2 centimeters would be? 10. And that means vertically, are you sure? Let's count 1, because I'm counting 0, 1, I'm using 2 centimeters, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then I can leave some small space here. I have 12. Now if you happen to put an axis in the middle, that means you have roughly like 2 centimeters, you'll have like 6. If you counted 1, 2, you'll have 6 up. Now if we wanted to put a scale that includes 100, how shall we achieve that? If you wanted 100 to appear on this scale, you have to have 6. Yes, Mokisa?
Which I think its scale would represent 50.
50?
But 10. But 10 is...
Assuming you write 10, will you reach 100? How many times? Yet you have 5, 6 boxes up?
I think you can use 50.
50, you would say 0. 50, 100. That means you don't have used 2. You leave a lot of space up. Yes.
I think we shall have to reduce.
To reduce the 100 to like now we are going to introduce a mathematical method of dividing. We shall say we shall be counting how many boxes do we have that I have to use up here. Of course, you will have decided whether you are using 1 centimeter boxes or you are using 2 centimeter boxes. Now if we are using and want to make sure 100, because I have 0, I have to end with 100 somewhere up there. I would count how many 2 centimeter boxes are available for myself. We are saying that there are around 6. If you looked at a normal graph paper from the middle, you count 1, 2, 3, 4, 5, like 6. 6 up, 6 down, 2 centimeters, but 1 centimeter would be 12. Now we divide this by 6. Then we must make sure that the scale we are going to use is either a multiple of 1 or what? Or 5. And sometimes what? Well, because a multiple of 2 is also a multiple of 4. That means divide 100 by 6. It gives a clue.
Yeah.
What do you get? 16. Which clue do you get? You now either choose a value higher, which is a multiple, or below. 15. 15 is a multiple of 5. Yeah. And now when you choose 15, you must see, whenever you reduce to a lower value, the scale of many values will be used. Therefore it might exceed. You test 0, 15, 30. Will you reach 100? How many from 15 you would say? 0, 15, 30, 45, 60, 75. What are this? Plus 15, 90. How many are these? There are how many? 1, 2, 3, 4, 5, 6. 100 is not yet.
Then you can use
That means you use a value. If you use below, it will accumulate very many values. If you use a higher value, you'll be able to fit. That means you can use 0, 20, 40, like that. It would reach. That means whenever you are finding out you try to divide by the boxes by the biggest value of y, or of the axis that you have, because you can have also a scale having, you can have 2 values to plot. You will have 2 and negative 50, then 5 and this. Now also the choice, the level where you draw the x-axis matters very much. If you are if the y value, let me try to rubble this. We are trying to explain that graph paper. If you are plotting 2 with 100 and 4 with negative 50, you see that you have very many positive y values than negative y values. You will also, where you place the x-axis, you will have to put much of it, leaving enough space up than down. That means learn how to place the graph, the x-axis with respect to how many values are you going to include for each axis. That very, very correct. Yeah. Now, any question on how to plot? Hope you have understood. If we asked the scale for this, can you state it? What would the scale be vertically?
2 centimeters.
Represents 20 units. That's very good. Every 2, if you use the one would squeeze work. Unless otherwise, where using 2 is almost impossible. But even if you are using 1, if you have put here 1, why can't you put it 2? Why can't you skip 1 and just put it 2? But knowing that 1 is in between 2 and 0. That means squeezing on 1 centimeter is not good enough. Not good enough. Our people are now clear with plotting. Not so? Yeah, people are clear with plotting. I want to give you some small work you plot for me, and we try now to go to plotting polygons. I think we can do that concurrently. Now you are set, not so? Plot the following coordinates. Plot the following coordinates on a graph paper. On a graph paper. You have 5 to 3, 4 to 8, 7, 9, negative 1, 3, 0, negative 6, then negative 4, 0. That's what you are going to plot on the first one. I hope you have what I'm plotting.
5 2
5 2 3 4
2 8
2 8 7 9
negative 1 3
negative 1 3
0 negative 6
negative 6
negative 4 0.
negative 4 0. Okay, you're only using 2 minutes, and you'll help me to discuss out fast because I expect you to use a graph book, not so? And which axis would be, which axis are we putting, how are we putting the, look at the y values, the y values first. Which one is the biggest positive value for y?
9
9. Negative 6. That means you would have many positives than negatives. Where you are putting your x-axis will matter, not so? Yeah. That means you put it a bit more, like 3 times, almost 2 times more than down, yeah. And some of you neglect drawing those lines. You think because the graph paper has lines, you neglect, don't. And don't forget the 0. And make sure on your graph paper when you are plotting, for every 2 centimeters, what are we using there?
2 units.
2 units. Because 1 centimeter will become 1 unit. Therefore, from here is 1. No need to label it. Congestion. That means you can use 2 for every 2 centimeters, not so? 6, 8, and you're plotting the values must be close to the axes. Mark where you are plotting on the graph paper. Then 10 to, these are 2 centimeters. Label y axis. Then label x. Make sure you are using 2 centimeters. Yeah, that's right. Then horizontally, which values do you have as the biggest?
7
We have
positive 7
+7. The negatives?
negative 4
That means our axis should be more this side. Yeah, ensure that your axis has a few negatives. That means on your graph paper, extend it, the axis more towards this side. How many units are we using?
2 units.
2 units for each. 2 units also. 2 units also. This is 6. This is 8. Not so? Yeah. I hope we can plot very fast. Then this way you have -2, -4. These are how many divisions there? There are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Using 10, 10. Plot and we see. Label well X and Y axis. I hope you are plotting now. That means 5, 2, 5, 2 be where?
5 of the x-axis.
This stands for X, horizontal move, vertical what? Move. That's 5 in between here. And what?
2.
And 2. Use a single cross like that, or you use a dot and a small circle. The one that looks more attractive for you is what you use. Then you plot 3, 4, 3, then 4. Then you plot 2, 8, 2x, 8y. Then you plot 7, 9, 7, then I hope you know where 9 is between here. Then -1 in between, because this is 0, 1, and so on. -1, 3, not so? 3, then 0, 6. What is 0, 6? Yes. 0 is on the which axis? X. Then the y value is -6. Then -4, 0. Negative is the x, not so? Y is what? You first look for -4, which is here. Since 0 means no, 0 distance moved, you remain there. That's clear. Now, upon that discussion, I wanted, ensure you have labeled your mark table, not so? Now, I wanted to ask, assuming we were looking at plot like 2.2 and maybe 1.5, yeah. Now there you are. How do we plot that? Like 2.2.
You move
like let's say 2.2 with the 3. Let's say you are plotting that 2.2 with the 3 and 1.5 with the -0.5. (2.2), how do we locate that? Yes, Grace.
we shall have to first draw all those small units from 0.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yes. Then we shall base on those.
To locate 2.2?
Yeah.
How should we locate that?
Because
5 is?
The fifth unit is 3.
And the fifth unit is 3.
Between 2 and 4.
Between 2 and 4, the fifth one is 3.
Yes.
You're saying here is 3.
Then we shall use those 5 between 2 and 3.
How?
Indicate.
2.2.
We shall have to divide it into 10 small units.
We shall have to divide the 5 into 10 again to locate the
But
2.2.
You can use a ruler. Since those 2 units,
Each is represents a centimeter.
Yeah.
Then you can use a ruler to locate. That's one method. That's very, very correct. That means you can get a set ruler because from here to here is 1 centimeters. But remember that you see from, if this from here to here was 1, you did say 1.2. If this was 1, 2, 3, if you are not having a scale of 2, 2, 2, you easily locate 1.1, 1.2, 1.3, but now this one is between 10 divisions is 2, not 1. Now, the ruler would deceive. The ruler would not deceive, but it would not be in line with the graph paper, since the graph paper is not using 1 unit for every 10. That's all? Yeah. Now, the easiest way to do it, math is the best. Now, how do we achieve that mathematically? Whenever you are trying to locate a decimal unit, what we do, we must work out what does 1 represent. What does 1, we call it what does 1 small square represent. This is the small square because 1 small square, 1 small square. Mathematically, we just see the difference between here and here is 2. Not so? That 2 we divide by the number of small squares between here and here, which is 10. That means each 1 small square is just always the range between 2 boxes out of the number of what? Number of smaller squares. That means you can locate, that's our range is what? From here to here is 2 divided by 10. 1 is 0.2. Not so? Now if 1 is 0.2, to locate 2.2, there are again 2 ways there. You can get 2.2 divided by this, then you will count from 0 up to those 2.2 divided by 0.2. What would you get? 11. It means you count 11 squares from here up to here. That means you would say 1, this would be 10, not so? Yes. Then the 11th is here. That means 2.2 would be here. Is that hard? Now somebody might be wanting to locate from here. Again, that would make again more math. Would make again more math complicated. If you wanted to locate from 2 where 2.2 is, you now subtract 2.2 minus 2 divided by this. You know how many boxes should I count from 2. 2.2 minus, if you wanted to count from 2, not from here. If you want to count from the start, then you have to get the 2.2 divided by 1 square. Then you count every time from here. Like if you wanted to locate 6.8, you get 6.8 divided by this, which would be? Which would be 6.8 out of 0.2. That would be 34. You do count, because you know that from here is 10, 20, 30, then you count 4. That means, how do you locate? Maybe since people have already plotted, we can discuss more on such work that you are locating decimal values. Because somebody would be now, how will I locate 0 point something? Like if your scale was every 2 centimeters representing 5. This is what? 10. Now some students make a mistake. He can put 5 at 1 centimeter, then others maintain at 2 to what? That's a mistake. If you are using 2 centimeters, let them be 2 centimeters throughout. Now if you wanted to locate, like if you wanted to locate, let me use this coordinate as 4 with the 15.8. Now this is the y value, not so? And this is x. Now I would first work out what does 1 small square on the vertical axis mean. 4 is already known here. Now what does 1 mean? Since there are 10 between here, I would divide 5 divided by 10. The interval divided by 10, I will get 0.5. Each now here is going to stand for 0.5. If now I wanted to locate 15.8, I get 15.8 divided by 0.5, then I would know how many to count from here past this one. How many? This out of this. You get 15.8 out of 0.5, you get 21.6. 30, you get 31. Therefore you count 31 from here. You know this is how many small ones are here? 10 plus 10 plus 10, 30. Then an extra 1. 0.6. Then you round off to 32. You got 31.6. 31.6, you round off to know how many of them are there. Round off to 30, so therefore you count 32. Again, estimating after division is also, we can estimate that that's again more disturbing. Just round off to how many whole number small squares. Hope you can plot decimals. Precious. And also I've told you, how do you identify a scale for big values? I hope you've understood. We said, how do you identify, how do I fit values up to like 500? Because we can say, plot the biggest possible y value, maybe goes with 5 and 500. You would say, we said 500, you would now count up here. Normally, your graph pattern don't change. If there are normally 6 or 5. You can divide 500 by 5. You can have it constant in your head. Of course, you'd first compare with the negative ones. If you happen to have, now these negatives are meaning down, you have smaller space than up. Then it means up the boxes might increase like to 7. If you try to say, let me leave more space up, then you divide 500 divided by 7. 2 centimeter boxes. And what you get must be among these values, or their multiples. Like 500 divided by 7, what do you get? 71. Now 71, which multiple is nearer there of any of these?
For 5 we have 70.
70?
For 2 we have
No, it must be a value having the one, no, let me say it right. it must be a value having, it must be a multiple of them, but having it 1 or 2 or what? You didn't take what? 70. You would take now what? A value 50, or it must be a value having a 5, a 2, or a what? Means you would now take there either 50 or 100. That's tasking. That means you would use 100, 200, 300, 400, 5. But mentally you can even work it out. You can see what if I tested 50, if the value is big, then I can't use 2. You keep adjusting. Let me use 10, 10 can't fit. Let me use 20, 20 can't fit. Let me use 50, 50 can't fit. Now 100. That means you have 1, use 1. If 1 can't use 2, 2 can't fit 5, 5 can't fit 10, 10 can't fit 20, 20 can't fit 50, 50 can't fit 100. Multiples, but they must have digits 1, 2, or 5. Okay, that's finished. I've discussed that plotting. If there is any problem, some candidate can ask. Now we are going to plotting polygons. Plotting polygons. It means you must have the skill of plotting for any values that have been given to you. Now, I hope people know what polygons are. What are those polygons there? Our common polygons, do we have, maybe before you plot them, a review? What are they? Yes? Squares. A square has what's the property? All sides are equal. And that means if you plot a square, if you plotted the coordinates upon joining all the units, the measurements are the same, then you have got a square. I will give you some 3 coordinates and ask you to locate the 4th. If we gave you this and this and asked you to locate this, can't you? How do you achieve that? Yes, Grace?
You will have to use the second number, the second digit of the x-axis and the upper digit of the y-axis.
Yeah. You use this value and this one to locate this. That's marvelous. That's marvelous. That means the square, all sides are equal. The next one, a rectangle. People can locate if you are given a few. Rectangle has 2 sides equal and 2 sides equal. That means you locate the other coordinate in the same way. Not so? Next, triangle. And here there are very many. We have so many. As long as you have a 3-sided figure, not so? Yeah. What else?
A kite.
Kite. How does a kite look like?
It looks kind of
Parts are slanting.
yes, kind of.
Like this.
Yes.
These are shorter than. Not so. That's a kite. What else? Trapezium. That means what you plot and you see is what you'll have got. Not so? Yeah. Now, I want to. Polygons are many. Not so? I want to give you some polygon here. You plot. Are you ready to plot? Plot the following coordinates on a Cartesian plane. Plot the following coordinates on a Cartesian plane. That's A11, B24, C44, are we there? Yeah. Part B, locate point D that would make ABCD a parallelogram. You are there? That would make ABCD a parallelogram. How does a parallelogram, its properties? How does a parallelogram look like?
It has two sides equal.
How does it look like? Is it a rectangle?
It is like a rhombus, but a rhombus has all sides.
A rhombus has all sides equal. Is it that
Yes.
two sides are parallel? Not so? That means if you plotted A, B, and C, you can get D. Okay, try to plot and we see. And I think the choice of the axes, I see no negative values there. Therefore, where you place the axis will matter. Would it be fair? How have you handled that scale there for every 2 centimeters? How have you handled that?
1 unit.
1 unit. Why?
Reason being the hidden units still form those arrays.
There are very few. Two minutes. Have you located the other coordinate? How?
3, 1.
3, 1. I'm wondering how you located the 3, 1. Which one was unknown? Is it this or this?
Twice
This one. It was this?
down.
It was down. Which one was that? Was it this corner or this?
Twice the down.
This corner was unknown. How did you arrive at that upon joining only that?
And perhaps this parallel is facing up.
It's facing up.
Yes.
It's not slanting like this. Maybe let me plot it here. You used also 1 unit here for 2 centimeters? Not so? Then you'd help me and read for me what you plotted there.
1, 1.
Have you labeled well those axes? You plotted 1, 1, which is point what? A. Then point B? 2, 4. 4, 4. Here?
Yes.
4, 4 is C. How did you achieve that? You joined here. Not so? Then joined here. Not so? Then, how do we achieve the other one? Yes.
2 sides.
Yes.
Sides have to be equal.
2 sides have to be equal.
So that upper part there were 2 centimeters.
And you had to measure. You measured here. And also measured here. They have to be the same. You have to measure here and here. That was very accurate. Yes, so you have another one.
So even if mine was not accurate, but still. Okay. I based on the distance left between point A and point B.
You based on the distance left between point A and point B.
From point B to point A. Then I found out that it was 1 centimeter. So it's the very same centimeter that I used to determine from point
Here.
C.
Okay, there are many skills there. Yeah. Of course, others can use geometry. Can use a set square if they have a set. Can use a set what? A set square. And let me put it in such a way. Hope it will work out here. Because I wanted it to rotate this. Okay. Some can use geometry, and this square seems not. And that means, okay. That geometry seems to be does not seem to work out well here. But geometry can work very properly. Geometry seems naughty. Are you trying to use geometry? That you slide it until it catches with that. You slide it along a ruler so that it doesn't move. You are sliding along. No, you have to fix one ruler. Then the other one would be movable. I don't know, I mind. Maybe my set square does not seem to help me at all. Yeah, I think this would be pretty. I'm first fixing this along this. I think you saw it disturbed me to locate how to put it. You see? Now you can slide it until you reach that. I don't know, you'll be able to see that I've reached that point. Slide it. When you reach that point, you'll know you try to play with them in a way that you will slide one while one is fixed. You can test that when you have enough time. Okay, now that's all with the plotting polygons. You can try many as they will be given to you in the exercise, but we can go to this part called the drawing graphs, and that's the end. Drawing graphs. Now before we draw graphs, what's the relevance of what we are doing? What's the importance? Are we really wasting time with plotting on graph papers and so on? Where can we really apply this? Yes, Mokisa. Where?
When maybe finding the distance between places. Places on a map.
Okay.
And then the graphs can be used to determine the number of people, amount of something.
Okay. It means we are not wasting time. Okay. I think you've viewed also those who do carpentry. Like that skill, while I've been moving things, they can use them to locate where to cut accurately. Cut whether like this, cut in any order of their cutting. Okay, let us automatically run to drawing graphs, and you know that graphs are more easy to tell you what to explain events than you viewing information collected in a table. A graph will speak for itself, not so? Increasing quantities will be shown graphically, and reading, comparing two things on a graph would be easier, not so? Now, directly, I would immediately give you this graph that you should plot. You should plot it and we discuss it. You are set there? Yes. Complete the table of values for. Complete the table of values for y is equal to 2x minus 4. Y is equal to 2x minus 4. You complete that table. Y is equal to 2x minus 4, xy. Then you have from -3, -1, 0, 1, 2, and 3. You complete that table. How are we going to work out that? First have part B there. Draw the graph. Part B, draw the graph. Draw the graph of y is equal to 2x minus 4, 2x minus 4. Part C, show that point 32 lies. Show that point 32 lies on the line, and point 31 does not lie on the line. How are we working out that? And we plot Yes, Mokisa Grace.
I think we shall have to first fill in the table by
Fill in the table.
substituting those for x to find y.
Those for x, when x is negative 3, then we substitute. That means y will be minus 4. This will give us
Negative 6,
minus 4, giving us
negative 12.
negative 10. When x is negative 2, y would be 2 times negative 2 minus 4, giving us minus 4 minus 4, negative 8. That means work out for me the rest, negative 8. Have you worked out the whole table? What do you have? What do you have?
Negative 6.
You have negative 6,
Negative 2.
negative 2,
Negative 2.
negative 2.
No, teacher.
Yes.
On 0,
On 0, when x is 0, you have
I've got
negative 4. Not so? Because you say 2 times 0 minus 4, which is 0 minus 4, which is 0. Since 0 is nothing. Then here,
negative.
negative.
No, 0. Yeah, it's 0.
It is 0. And lastly,
Positive 1.
positive 1,
No, positive 2.
positive 2. Now, you can plot those coordinates. I hope you are going to select the scale very well, looking at the x is balanced, negative 3 and negative 3, and positive 3, but y is not balanced. You have negative 10 and the positive what? 2. Therefore, I expect that your graph paper should be such that where will you have x will be balanced, but y you will have many negatives, no sir? That means a lot of a small space should be left up, small space up. Does 1 unit fit on your graph paper? If you counted how many boxes, do they reach 10 now? If you left, because here you only need 2 up, that means on your graph paper you should leave 2 boxes as free space for writing other things. That's free space of 2 boxes, 1 centimeter. Then if you counted the up here and counted from down, does 1 centimeter fit for every 2? Will it fit for every 2 centimeters, 1 unit? Does it fit? Now 10 of them? Yeah, try to fit them down, you see. You have used 1 centimeter, 2 centimeters. Grace Precious has used. Why? Isn't it congested? Does it look very beautiful or it looks congested? Okay. Looks beautiful. But I advise you work with 2 centimeters. It's more attractive. Not so? Then you try to, here I think 1 centimeter for 2 centimeters for 1 unit. 2 boxes for every 1 unit. Not so? Because here there are few. And it's balanced. It's balanced. You can extend up to 4 because we need many. We are plotting up to 3. Are we through with plotting? I hope people are through. Which type of graph have you got? Have you got a zigzag things or you have got something like that?
Yes.
Then label on it. Label well these axes, x-axis, y-axis. And I would prefer that we indicate the scale in this corner here. Can you put our scale there? Scale that is vertical. Vertical, what have you used? And horizontal. For you have used 1 centimeter for how many units? Represent how many? 1 unit, not so? 1. But she has used 2, you write the scale clearly there. In that corner, in the left hand corner of the graph paper up here. Grace, have you arrived? Because we want to see that I wanted to give you a graph with very big values to plot, like 25. Label on the line, what line have you plotted? Y is equal to 2x minus 4. Now, the question said in part B that show that what? Part B was plotted, then part C? 3, 2.
Lines on the line.
Yes, show that this one lies on the line. We just substitute in the coordinates. This is x, this is y. We just put in there. If the two sides are the same, then it lies on the line. Our y is what? To put in the positions, 2 equal to 2 times what? 3 minus 4. 2 is equal to 6 minus 2 is equal to 2. When you get similar sides, it shows that this point lies on the line. You can even check it. You can check. Do you have point 3, 2 on the line?
Yes.
Yeah. If you prolong your line, it will be there. Check 3, 1. 3, 1, does it lie on the line? No, but it can be proved here. Put in also here. What is your y? Y is 1 is equal to 2 times the 3 minus 4. 1 is equal to 6 minus 4. 1 is equal to 2. So point, therefore point what? 3, 1 does not lie on the line. I think you have even seen it there. Yeah. Now, the big graphs, you'll discuss it in the exercise. I'll give you the exercise where you'll plot 25, 100, like that. Now, let us see, just look at graphs in real life. Graphs in real life, and we can end there. Graphs in real life. Which information can we put on a graphs, and where are some real life examples where we can find these graphs? We have seen that graphs involve plotting two quantities, not so? Two quantities. Not so? Therefore, they can be used to compare two quantities, like which situations? Yes, Grace.
Like boys and girls in a class.
Which aspect are we comparing for them?
The number.
Number of boys and number of girls. Shall we compare that? It must be changing, or you'll compare in a week.
Yeah.
Because if you said today, let me check, you'll find out that if you compared one day, it can't work. It will only have two values. Today they are 50 and 60. Where the two situations are changing, and you can compare them graphically. Yes, pressures, try.
Rainfall and temperature.
Yes, temperatures with which parameter? Temperature, because you will plot temperature against what? Time of the day, in the morning. Not so? You can look at how temperatures are varying from morning to evening, or they are varying after every 1 hour. What if you go in a taxi on different days and you compare the fares, the taxi charges per day. In the morning they charge different, afternoon different. It means you must have things that are changing. One thing is changing in the morning, one thing is changing. One thing is changing, another one is changing. Not so? Let me give you this one, this real life graph, and you can interpret it, and you'll research on other graphs. You research on other graphs. We can discuss out this one. The graph shows, the graph shows the fares charged by different taxis for different distances. Then we can have that one. Now we must notice that graphs in real life mostly don't have negative, except for temperatures, but most of them you can't compare negative money. Tax can't charge negative, meaning most graphs in real life have only positive axes, and therefore when you are given, they will only have, we shall not have the other axis down for negatives, no? They will only have the positive axes here. That means on your graph paper, I'm going to request you to just use to what? I'm going to give you what to put on the graph where the lines will pass, but you are going to use an interval of 2 units for 2 centimeters, 8, 10, 12, like that. You see I've eliminated the other axis, not so? But horizontally use 1 unit. Add that to your graph. That means you are going to, if you have a graph paper, you are going to start from down here, not so? From down here. You leave 2 centimeters. That means you leave 2 boxes here and 2 boxes there. Draw those axes. Then I give you this, how this line moves. This 5, 2, 3, 4, 5, 6. On your graph paper, you are going to you pass it through 4, 8. From here, you see 4, 8, don't mark it. I want you to just place it on your graph paper accurately. 4, 8, have you located 4, 8? Here, don't put a plot here. Just locate it. Then draw a straight line from here through this to end at 8, 16. Do you have 8 there? Yes, to end at 80, 16 here. That means draw from here, my graph paper. Draw and end at where there is 8 and 16. 8, 16. Have you put that? Because we want to discuss that graph. Have you put that? Have you taken up to 80 and 16 up? Yeah, are you there? Label that one taxi A. taxi A. Then the other one 4 at 4 for taxi B. Are you there, taxi B? But for it, it should end at 10:14, taxi B. Taxi B, have you captured that? Taxi A finished. Taxi B, go at 4. Go at 4. Then where you passed at 4, where there was 4, 8, the same point pass there, they all pass at 4, 8. But end on 10, this one will end on 10, 14, this one will end on 8, 16, somewhere. Then we discuss that graph that has been given to you. Taxi B. You have taxi A up here, then taxi B. Then here you have distance in kilometers. Label down there distance, kilometers. Then label here costs in shillings. They all pass through this, but this one starts at 4, ends at 10:14. That's an example of a graph in real life. Ten, 14. 10 down, then corresponding 14 up. Then the first question, we give you the first question now. Part A of that graph question has questions below it. Part A says that how much does each taxi charge for a journey of 7 kilometers? How much does each taxi charge for a journey of 7 kilometers? Is that answer right in your head now? Then the other part, how much does taxi A charge for each kilometer? How much does taxi A charge for each kilometer? Taxi A charge for each kilometer. Then lastly, what distance will cost the same amount of money? What distance will cost the same amount of money? Okay, that's the end of that. Can you give answers for such a typical graph? And how much does each charge for each kilometer? For 7 kilometers. How are we going to achieve that? how much does each charge for 7 kilometers? Yes, Grace?
You have to place on the x-axis
the distance of 7 kilometers. That would be somewhere.
Then you go basing on the point of
That means you draw a dotted line up to each taxi also and read its costs. That means draw a dotted line and read the cost for each taxi point on your graph paper and read the cost for each taxi. What is the cost? $9 shillings for taxi.
for taxi B.
Taxi B has 9 shillings. I hope on yours it will read accurately than my BB. Okay. What is the accurate one on yours for taxi A?
But teacher, the question is saying 6 kilometers.
6.
8 kilometers.
The same?
Yes.
The same?
It's saying for 8 kilometers, not 7.
For 8 kilometers?
The question is how much does each taxi charge for a journey of 8
7 kilometers.
7.
Okay, assist me in part B. I think you've located accurately.
Teacher, for taxi B,
Mm.
got 14 shillings.
14 shillings. Then taxi A.
Taxi that was 16.
16 shillings. Okay. Hope your neighbor the same. That fine. She's fine.
You just need to explain
For her. For you can't explain for her. Now you have to go at 7 because 7 and make sure you don't touch the first line. This is for taxi B. Then you'll also continue.
Teacher, should it be just at the line or at the point where the taxi is?
No, where you see 7, you go up to where you meet the line is where you continue.
Then meaning taxi B,
Mm.
it is 11 shillings.
11 shillings. Then
14.
14. That's okay. Okay, question 2, part B. Part B says,
How much does taxi A charge for each?
what does it charge for each kilometer taxi? Each kilometer? How are we arriving at that? Yes, Grace?
You have to base on the distance between each kilometer and the point of the costs where it reaches.
Like here?
Yeah, 1 kilometer it will reach 2.
You
According to my
to you as it will be at 2. Then for the other one,
2 at 4.
They wanted for each taxi both.
No, for taxi.
For taxi A, that means you don't read for taxi A. How many, what they cost?
For each kilometer, it charges 2 shillings.
2 shillings. Okay. That's good. Okay. Now lastly, parts, what does it say to you?
The distance will cost the same amount of money.
There you are. Each distance will cost the same amount of money.
2 kilometers.
Each distance will cost the same amount of money. How are we arriving at that?
Teacher, is it for both taxis or just?
That each distance is the same for both is the question saying.
4 kilometers.
That's the meaning of the question.
Because that's where both the taxis meet.
Exactly. That's at 4 centimeters. But you have to demonstrate on the graph with dotted D. Okay, now that's all with the Cartesian coordinates, rectangular Cartesian coordinates, and the graphs. Plotting, I hope you've learned how to plot, not so? Make sure that these skills are in you. Using a graph paper, do you know how to use it? Plotting both small values and big values, stating the scale, not so? Plotting decimal numbers, there you are. Locating one small square, do practice there. Now, make sure you can locate points of a polygon that are missing. Also, and lastly, working with graphs in Rio. I received this activity of integration and we will close that topic. It says here, a senior 1 learner has reported in her class. A senior 1 learner has reported in her class and has settled at her desk. And has settled at her desk. The mathematics teacher has asked her to explain how she can access her seat. The mathematics teacher has asked her how she can explain how she can access her seat. Starting from the entrance of the class. The classroom is arranged in rows and columns. It is a big class with each learner having his or her own seat. Basing on the knowledge of horizontal and vertical lines, discuss whether there are other ways of reaching her seat. Discuss whether there are other ways of reaching her seat. Thank you for attending. We meet in the next topic.